Good morning. Welcome to another edition of A for A levels. This is my tutor, and today we are going to go through Pure Maths Paper 3, February March 2020. This is Paper 3-2. First question, sketch the graph of y equals to x minus 2. Okay. Graph of y equals to x minus 2 will be a graph that is like that. So, a graph of modulus of x minus 2 will have this part here reflected on the x-axis. Okay. So what I'm going to do is I'm going to erase this graph. I'm going to draw the top part and the reflection. Okay. So this will cut to, instead of -2. Okay. Next, solve the inequality. X minus 2 is smaller than 3x minus 4. So this if you look at the graph, most books will ask you, or teachers will ask you to square both sides of the equation. But if you square both sides of the equation, you will have two solutions. But if you sketch the graph, 3x minus 4 here, you will have only, this is y equals to 3x minus 4. You will only have one solution, one point of intersect. So there's only one inequality for a solution. Okay, so how do you get this point here? So what do you do? This part of the graph is y equals to minus x plus 2. So you need to solve the equation minus x plus 2 equals to 3x minus 4. So you have 4x equals equals to 6, not minus 6. Okay, so x equals to 1.5. So this point here will be 1.5. So the inequality is x minus 2, which is this graph, is smaller than 3x minus 4. So smaller means the graph is below this graph, below this graph. Change some color. So it's below this graph. Okay. So the part that's below this graph is here. So the solution is x is larger than 1.5. Now, if you try and solve by the recommended way, if you square both sides of the equation, then you have x squared minus 4x plus 4 smaller than x squared minus 12x minus 24x plus 16. So you have 8x squared plus minus 20x plus 12 larger than 0. Divide by 4, you get 3x squared minus 5x plus 4 3x x minus 24 x 4. This is 4, this is 3 here. Something is wrong. Oh, this is 4, sorry. This is 2. I make some mistakes. Divide by 4. This is 2, and this is 3. So you have, now it's correct. 2x minus 3, x minus 1. So in this solution, you will have x smaller than 1, x larger than 1.5. So the solution is definitely wrong. Okay. Now, let's go to the next question. It's tricky first question. Solve the equation ln 3x, ln 3 plus ln 2x plus 5 equals to ln x plus 2. So here you make it into one logarithmic term on the left-hand side equals to ln x plus 2 square. So you have, take away the ln, you have 6x plus 15 equals to, square this side, x squared plus 4x plus 4. Writing it in the general form, minus 2x minus 11 equals 0. Let's see, okay. Now they want it in simplified exact form, so you have to use the quadratic formula. 2 plus minus b squared, which is 4 minus 4ac, minus 11 and 1 over 2. So we have 2 plus minus, this is 4 plus 44, which is 48. One plus minus root of 48 is 4 root 3. So become 2 root 3. Now, because this is a logarithmic equation, the ln must be a positive value. So if you take x as 1 minus 2 root 3, then the solution, the equation is not valid. And also there's a clue here, answer only, not answers. So the solution is just x equals to 1 plus 2 root 3, which is in the exact form. By sketching a simple pair of graphs, show that the equation x 2 minus I has exactly 1 root in the interval 0 and half pi. Second x is 1 over cos x. So this is your asymptote at half pi. This is y, this is x. So the graph secant x is this. So this is 1. So this y equals secant x. 2 minus half x, 2 here, 2 minus half. So half pi is 1.51 is here. So this is y equals 2 minus half x. So you have one point of intersection. One solution. Okay, verify the calculation that this road lies between 0.8 and 1. Okay, now let fx equals the secant x minus 2 plus half x. So you have f of 0.8. Let's see what the answer is. So when you ask to verify, you just need to show one of the answer is a positive value, one of the answer is a negative value. So this is plus 0.8 2 plus 1. So this is minus 0.16 f of 1. This is 0.35. So there you have it, one positive and one negative. And you can make a conclusion that solution lies between 0.8 and 1. Okay. Use the iterative formula xn plus 1 equals to arc cos 2 over 4 minus xn to determine the root correct to 2 decimal places, give the result of each iteration in 4 to 4 decimal place. Here I would always like to put in a table. And so x1 when n equals to 1 will be your first approximation. I will put it right in between 0.8 and 1, which is 1.9. So x2, just key in your calculator. So this is a cos 2. Okay. Seems to be. Oh, sorry, this is 0.9. My bad. Okay, that's better. 0.8696. It's 777. It's 756. It's 761. So if the numbers are near, it's 760. The numbers are already near, then you can approximate it into 2 decimal place, which is 0.8. That's it. Find x second square x, given your answer in simplified exact form. So when you have a mixture of trigonometrical function and the linear x function, is usually integration by parts. U dv equals to uv minus integrate v du. Okay. So what I'm going to do, I'm going to put u as x and dv as second square dx. So you have du equals dx. When you integrate this, you get v equals to x. So your x secant square x dx equals to uv, which is x tangent x minus v du. Tangent x du is dx. Okay. Now I'm going to put the definite values only after I finish integration. Okay, so this x tangent x minus. Now tangent x is sine x over cos x dx. Now this is in the form x dx. So when you integrate this, you get ln fx. So this will be x tangent x. Now I'm putting in the definite value plus ln cos x definite value is 1 over 3 pi and 1 over 6 pi. 3 pi 1 over 6 pi. Okay. So they want the answer in the exact value. So this will be equals 3 pi tangent 1 over 3 pi is ln cos, this is plus 3 pi minus 1 over 6 pi, then 1 over 6 pi plus cos 1 over 6 pi. Okay, now you need to know the exact value. Tangent 1 over 3 pi is 3. So this is 3 pi over 3. Cos 1 over 3 pi is half. So it's ln half minus tangent 1 over 6 pi is 3 over 3. So this will be 3 pi over 18 minus cos 1 over 6 pi is 3 over 2. Okay. Miss out the ln. It's a ln here. So this is ln 3 over 2. Okay, so this is times 6. This will be 18. 6. So this is 5 3 over 18 pi ln half minus ln 3 over 2. So it's ln 1 over 3. So plus ln. I'm going to simplify the ln. This is ln 3 minus half. Okay. So this will become minus half. That is the solution. Okay. So that cos 3x over sin x plus sin 3x over cos x equals to 2 cotangent 2x. Okay, now I'm going to start with the left-hand side, which is longer. Usually you start with expressions that are longer and you simplify it to a simpler expression. Making it a single fraction. X as the denominator, this will be cos 3x cos x plus sin 3x sin x. Now, the numerator is your composite function cos a minus b. So this will be cos 3x minus x over. Now this sine x cos x, sine x cos x, sine 2x equals 2 sine x cos x. So our sine 2x will be sine x cos x. Okay. So this will be half 2x. Okay. So this becomes 2 cos 2x over sine 2x. Okay. Cos 2x over sine 2x is cotangent 2x. There you have it. And solve the equation equals to 4. So this will be 2 cotangent 2x equals to 4. Tangent 2x equals to x equals to 0.464. This is the reference angle in the first quadrant, and the third quadrant is pi plus 0.464. X equals to 232 1.34. Solve the easily. Differential equation. The variables x and y satisfy the differential equation dy over dx equals to 1 plus 4y squared over e to the power of x. It is given that y equals 0 when x equals to 1. Solve the differential equation, obtain an expression of y in terms of x. Now first separate the variables. So you have dy 1 plus 4y squared equals to e minus x dx, integrating both sides. Now you can get the integral of 1 plus y squared from your formula sheet MF19. Let me draw it out for you. Okay. X squared plus a squared is arctangent x over a. So you have integrate 1 over x squared plus a squared dx is equals to 1 over a arctangent x over a. So you have to change this into the form. So I'm going to change it to, I'm going to times by 1 over 4. Times 1 over 4 times by 1 over 4. So I have 1 over 4 here. This is just dy over y squared plus 1 over 4. Okay. Now using the formula here, a squared is 1/4. So a would be half. So this will be 1 over 4. 1 over a will be 1 over half, which is 2. Arctangent x over half, which will be 2x. equals to integrate e to the power minus x minus e to the power minus x plus c. I'm going to simplify. Oh, this is y. Sorry. Okay, this will be half tangent 2y minus e minus r minus x plus c. Now, next step is to find the value of c by having y, given y is 0, x is 1. Substituting this value. So tangent 0 would be 0 minus e minus 1 plus c. So c would be minus 1 over e. Okay. So you have your equation half tangent 2y minus, I just write this as e minus 1. E minus x minus e minus 1. Tangent 2y equals to minus 2 e minus x minus e minus 1 plus 2y equals to tangent minus 2 minus x plus e minus 1, and y equals to half tangent is 2 e minus x plus e minus 1. Okay, this is the solution. Given a lot of space to do. Still, what happens when the value of y when x tends to infinity? So I'm going to write it in the rational form. So y equals to, y equals to half. So the solution is y equals to half tangent minus 2 x plus 1 over e. Okay. So as x tends to infinity, e to the power x tends to infinity, 1 over e to the power x tends to 0. So y will tend to half tangent minus 2 over. Okay. The equation of a curve y equals to x cubed. Let me see if I miss anything or not here. Okay, nothing. So this is implicit function. So in implicit function, you just differentiate each and every term separately. So differentiate x cubed, we get 3x squared. Differentiate 3xy squared is your product rule. So your plus 3x. Differentiate y squared is 2y dy over dx plus y squared differentiate 3x is 3 minus differentiate y cube is 3y squared dy over dx. Differentiate 5 is 0. Now, the next step is just to simplify. These two terms have dy dx. I'm going to factorize it. This is 6xy minus 3y squared equals to, I'm going to take is negative. Factor out minus 3 x plus y squared. Okay, dy over dx equals to minus 3 x plus y squared. Gonna factor out minus 3 also here. Get y squared minus 2xy. Dy over dx equals to, cancelling this, you have your answer. Okay. Find the coordinates of the points on the curve where the tangent is parallel to the y-axis. So the tangent is parallel to the y-axis. So it is, the tangent is a vertical line. Vertical line, the gradient is gradient undefined or denominator. Denominator 0. Okay, so your denominator of dy dx is equals to 0. So you have y squared minus 2xy equals to 0. Factorizing, you get y minus 2x equals to 0. So y equals 0 or y equals to 2x. Now let's look at y equals to 0 first. You have x cubed equals to 5. This one substituting into the implicit function. If you have y equals to 2x, wait. So this is x equals to cube root of 5. So you have already one solution. Now the other solution is when y equals to x. Substituting y equals to x, you get x cubed plus 3xy squared plus 3xy squared is 4x squared minus y cubed 8x cubed equals to 5. So here, x cubed plus 12x cubed minus 8. So you have 5x cubed equals to 5. Equals to 1. X is 1. So you're interested in the real values. So when x is 1, you substitute y equals to x, y equals to 2. And there you have it. You have two solutions where x is cube root of 5, 0, and 1. That's it. Find the coordinates of the points in the curve where the tangent is parallel to the y-axis. Oh. Okay. Erase this. The next question is a question on vectors. In the diagram, OA, B, C, D, E, F, G is a cuboid in which OA is 2 units, OC is 3 units, and OD is 2 units. Unit vector IJK are parallel to OA, OC, OD, respectively. The points M on AB is such that MB equals to 2AM. So this ratio is 1 to 2. Okay. The midpoint of FG is N. Express vectors OM and MN in terms of IJK. So you have now paper 3 vectors are like paper 1 vectors now. OA is 2, so this is 2I. Plus. So AM is 1 unit. G. That's it. This is OM. Next is MN. I'm finding OM first. ON first. So ON is OC plus CG plus GN. Okay. So OC is 3J. CG 2K. GN is I. MN. I'm going to write it column vectors form. It's easier to write now. It is MO plus ON. MO is -2 -1 0 plus ON is 1 3 2. This is -1 2 4 minus plus 2K plus 2K. Okay. And a vector equation for the line through MN. Okay. Vector equation R is equals to A plus TB. A being a position vector, B being the position vector. So R will be equals to, just pick a position vector of Mn. You can take OM or ON. Here I will take OM, which is 1 0. The direction of the vector is Mn, which is -1 2 2. That's it. Find the position vector of P, the foot of the perpendicular from D to the line Mn. So this will be 90 degrees to Mn. So the position vector of D, OD, is equals to 0 2 0. So let's put the point, the foot as F. So OF, position vector of F will just be the vector equation of Mn. So which is, oops. Two minus T, 1 plus 2T, and 2T. So this is a point of F on F, OF, the position vector of F, which will be the foot of the perpendicular. You find the value of T, you would find the position vector of, F. This will be P, because the question said P. Okay. So here the vector EP P O P minus O. So it will be 2 minus T minus 0, which is 2 minus T. 1 plus 2T minus 2, which will be minus 2, minus 1. Plus 2T, 2T minus 0. So since this line is perpendicular, the dot product will be 0. So dP, which is 2 minus T minus 1 plus 2T, 2T dot direction of Mn is -1 2 2. Since they are perpendicular, the dot product must be 0. So running this through this, you will find the value of t minus 2 plus 4t plus 4t equals 0. So t equals to 4 over 9. There you have it. So the point position vector of P, which is OP, substituting T, 2 minus T. 2 minus T. So 18 minus 4, which is 14 over 9. 1 plus 2T, 9 plus 8, which is 17 over 9. And 2T, which is 8 over 9. Writing it in IJK is 14 over 9I plus 17 over 9J plus 8 over 9K. That's it. Let fx is for express fx in partial fraction. So I'm gonna write this as a over 1 plus 2x. Okay, let's continue. So this will be plus b over 1 minus 2x plus c over 2 plus x. So you have 2 plus 11x minus 10x squared. Now you can only continue this if the degree of the numerator is lower than the degree of the denominator. C over x. Okay. Now I'm going to do just simple substitution to find the solution. First, I get x is minus 2. So this is 2 minus 22 minus 40 equals. So here, minus 2 is 1 minus 1. Oops. 1 minus 4. And 1 plus 5. 15. Minus 15c. This will be minus 60 equals to minus 15c. C is 4. Okay. X equals to half. So you have 2 plus 11 over 2 minus 10 over 4. 1 plus 1, 2. 2 times 5 over 2 is 5. 5b. So this is 4, this is 22. So it's 12 over 4, which is 11 over 2. 15 over 2. Equals to 2 over 3. Net minus half. So this is 2 minus 22 over 4 minus 10 over 4 equals to minus half. 1 plus 1. 2. 2 times 3 over 2. 3. 3a. So this is minus 32 over 4, which is minus 16 over 2. minus 8 is minus 6. A is minus 2. Let me see if this is 5b. Yes, correct. Okay. So the answer is minus 2 over 1 plus 2x. P over 1 minus 2x. 2 over 3, 1 minus 2x. C is 4 plus 4 over 2 plus x. Okay. Express fx. Oops, again. Hence, obtain the expansion of x in ascending powers x up to and including the term in x. So I'm going to write fx in its power form. Minus 2 2x plus half plus. Oops, okay, I'm going to put it as a minus. Minus. Plus 2 over 6. 2 over 6 is 1 over 3. 1 over 3 x minus 4 over x plus 2. Okay. So this can cancel out. This is just be minus minus 1 over 3 plus 4 x plus 2. Okay. Now let's expand each separately. X plus half. Oh, I made a mistake. I should not have factorized in such a way. Okay. I forgot to factorize not with the coefficient x. Let's do this again. Okay. So I'm going to rewrite this easier. So this will be 4 over 2 1 plus half x. Or it is 1 plus half x. Okay, in order to expand, you need the term to start with 1 plus something x. X power negative 1 plus 2 over 3, 1 minus 2x plus 2, 1 plus half x. Okay, let's expand the first one, 1 plus 2x. So this will be 1 plus -1 x plus -1 -2 over 2 factorial x squared. 1 minus 2x plus 4x squared. One minus 2x expansion plus -1 minus 2x plus -1 minus 2 over 2 factorial. So this will give 1 plus 2x plus 4x squared. Last one, 1 plus half x. 1 plus 1 half x squared. So this will give you 1 minus half x. So cancel off plus 1/4 x squared. Okay. Now fx, expanding, multiplying the first by -2, you get equals to -2 plus 4x minus 8x squared. Plus, multiplying the second one by 2 over 3 is 2 over 3 plus 4 over 3x plus 8 over 3x squared. Plus, multiplying by 2 minus x plus x. So this one can cancel off. So it is just 2 over 3. 4x plus 4 over 3x. 16 over 3 minus x. 13 over 3. Minus 8x squared plus 8 over 3. 24 minus 8, 16. Minus 16 over 3. So this is 32 over 6. 29 over 6. Complex number v and w satisfy the equation v plus I w equals 5 and 1 plus 2i v minus w equals 3i. Solve the equation for v and w, give you answers in the form x plus iy. X and y are real. So this is like a simultaneous equation. So v plus iw multiplying by I, the other equation. So you have I minus 2v minus iw equals to minus 3. This equation multiplied by I. Both equation, you have 1 minus 1 plus I v equals to 2. V equals to 2 over minus 1 plus I. Rationalize, multiply by minus 1 minus I over minus 1 minus I. You get minus 2I minus 1 square plus 1 minus I. So this is V. Substituting into the first equation, you have minus 1 minus I plus iw equals to 5. W equals to 6 plus I. Multiplying by minus I. So you get W equals to 1 minus 6I. That is the solution. On an organ diagram, sketch the locus of the points representing complex numbers Z satisfying Z minus 2 plus 3I equals to 1. So this can be written as Z minus 2 plus 3I. So this will be a circle with center, 3 radius. Remember your circles. One, two, three. This is 3. 2, 3. Radius 1. So I'm trying to draw by freehand. Okay. This is the locus of the point. Calculates the least value of argument of Z for point on this locus. So the argument will be tangent here. This is the argument. The least argument of Z. This is 1. This is a right angle. Sometimes you have to draw properly to really see how to solve the solution. So you want to find this angle here. Okay, so the argument of 2 plus 3I. So this x value, x equals to 1 over square root of 2 square plus 3 square. X equals 0.285. .983. Okay. Let me confirm the answer. as I suspected, this one was wrong. Two, 7, 1. So the answer theta would be this value minus this value, 712. Okay, that's it. So we have finished. If you like today's lessons, you can subscribe and like for future. You can get updates and future videos. You'll be notified. Fill in the comments if you need this paper to be sent to you. Please remember your email address. Okay,